How to use GDB debugging to find security vulnerabilities. Are you curious about how to use the new debugger to uncover security vulnerabilities in your programs? Let's break down the steps you can take to make the most of this powerful tool. First, always compile your program with debugging symbols. You can do this by using the -G flag when you compile your code. For example, if you are using the new compiler collection, you would run gcc-g-o program.c. This step includes source-level information in your binary, which is essential for effective debugging. Next, launch the new debugger with your target program. You can do this by typing GDB followed by the name of your executable, like gdb./program. If you need to analyze a running process or a core dump file, GDB can handle that too. Now, it's time to set breakpoints and watchpoints. Breakpoints allow you to pause execution at specific lines or functions where you suspect vulnerabilities might exist. For instance, you might want to set a breakpoint at input handling functions. Watchpoints are useful for monitoring changes to specific variables or memory addresses. This helps you catch unexpected behavior, such as buffer overwrites. As you step through your code, use commands like step, next, and continue. This lets you execute your program line by line, observing how data flows and changes. Pay close attention to variables, memory, and registers. Look for anomalies like out-of-bounds writes or improper pointer use. GDB also allows you to analyze memory and assembly code at runtime. This feature is particularly useful for detecting exploits such as shellcode injection or return-oriented programming chains. Use commands like X to examine memory and disassemble to understand low-level behavior related to vulnerabilities. If your program crashes, use the backtrace command to view the call stack. This shows you the sequence of function calls leading to the crash, helping you identify the vulnerable code path. Testing inputs is another critical step. Run your program with crafted inputs that might trigger vulnerabilities, such as overly long strings or malformed data. Monitor how the program behaves under these conditions using GDB to catch security flaws before they can be exploited. For more complex vulnerability research, consider automating your GDB sessions. You can create scripts to handle repetitive debugging tasks or integrate GDB with other tools to improve efficiency. By mastering these GDB features and techniques, you can systematically identify and analyze security vulnerabilities in your software. This approach aligns with effective debugging practices, providing you with detailed insight into program execution. With practice, you will be better equipped to fix bugs and strengthen your software security.